Assalamualaikum warahmatullahi wabarakatuh, and hi everyone. Today for the group presentation, our group choose title The Cataclysmic 1991 Eruption of Mount Pinatubo, Philippines. So basically this is our group members and my name is Nurul Nada binti Muhammad Nasran. Okay, now for my part, I will present on the history of Mountain Pinatubo. Mountain Pinatubo is a complex of lava domes located 55 miles northwest of Manila City, Luzon Island, Philippines. It was the second largest volcanic eruption of the 20th century. It was exploded spectacularly on 15 June 1991 and caused widespread devastation. Prior to the eruption, Pinatubo was a little-known volcano and it had been dormant for 400 years. Before the eruption in 1991, Pinatubo are remnants of older volcanic edifices of Mountain Pinatubo and hide it from views from distance. Pinatubo noted for a failed geothermal development project. Okay, next we move to the geology of Mountain Pinatubo volcano. Pinatubo was flanked to the west and probably underlain by the Zambales ophiolite complex, an easterly dipping section of oceanic crust which was uplifted in the late Oligocene. The second unit was sediments of the tar-like formation, mostly sandstone and siltstone in the older parts, and conglomerates and volcanic sediments and dikes in the younger. The tar-like formation was found in the north, east and southeast of Pinatubo and formed contemporary with the oldest known volcanic centers in the area, including Mount Mataba or the diorite of the Tizon mine, the subsurface remnant of an ancient vent. The ancient volcanoes of the tar-like formation originated from the same east-dipping subduction along the Manila Trench that continues to the present.
Hi, I'm Izwan. I will continue on history of Mount Pinatubo. Pinatubo is subduction-related volcano formed by the Eurasian plate sliding under the Philippines mobile belt along the Manila Trench to the west. Mount Pinatubo has molten material related to the complex tectonic associated with the subducting slab rise through the lithosphere and generate the volcanism typical subduction. The earliest volcanic activity at Mount Pinatubo is thought to have begun around 1.1 million years ago, but then ended several tens of hundreds of years. Mountain Pinatubo's modern phase of activity which started around 33,000 BC after a long period of dormancy. Next, we will discuss on chronology of eruption 1991. It was started on 16 July 1990 with the earthquake magnitude 7.8 hit 100 km northeast of Mount Pinatubo. On 3 August 1990, Mount Pinatubo started awaken after 400 years. Loud rumbling noise are heard around Mount Pinatubo and a landslide occurred near the summit and steam vents appear on the ground. In March and April 1991, hundreds small earthquakes happened. Magma rising toward the surface from more than 3,200 beneath Pinatubo triggered small earthquakes and caused powerful steam explosion that blasted three craters on the north flank of the volcano. And noxious sulfur dioxide gas were also emitted by the volcano. On 7 to 11 June 1991, magma reached the surface. The magma was out to form a lava dome but did not cause an explosive eruption. Then, in June 1991, evacuation 40,400 people at U.S. Clark Air Base. On 20 June 1991, ash eruption reached 20 km above the volcano, reawakening volcano's first spectacular eruption. 13 June 1991, ash eruption increased even more, creating a plume reaching 25 elevation after a short pause of 28 with no explosion. On 40 June 1991, a violent explosion occurred at 1:09 p.m. The eruption column rose to 21 km in 15 minutes. Hot pyroclastic flow swept through the valley around the Pinatubo. On 15 June 1991, volcano exploded in cataclysmic eruption that injected more than 5 cubic kilometers of material. The ash cloud from this climatic eruption rose 35 kilometers into the air. At lower altitude, the ash was blown in the direction by the intense cyclone wind of the coincident occurring typhoon, and wind at the higher altitude blew the ash southwestward. Evacuation continued to move out people from 40-kilometer radius.
Hi, my name is Yusuf, and today I and Adel Rahim will talk about the type of eruption products from Mount Pinatubo. The first product is magma. The magma oozed out to form a lava dome, but did not cause an explosion eruption because it had lost most of the gas contained in it on the way to the surface. However, millions of cubic yards of gas-charged magma reached the surface and exploded in the reawakening of volcano's first spectacular eruption. The Mount Pinatubo erupted about 5 cubic kilometers of magma, mainly during the paroxysmal, which is the sudden outburst June 15 eruption. Most of the erupted magma was dacite, which is the extrusive igneous rock intermediate between rhyolite and andesite, with an overall constant composition which has 64.5 weight% of silicon dioxide, but with variable amounts of phenocryst, which is a large or conspicuous crystal in a porphyritic rock. Small volumes of andesite, which is the family of fine-grained extrusive igneous rocks that are usually light to dark gray in color and have the 56 weight% of silicon dioxide, characterize the June 7 to 12 dome building phase and the June 12 eruption. This andesite contains inclusion of a primitive basalt which has 50.6 weight% of silicon dioxide. The dacite is extraordinarily enriched in sulfur, most of which is present as phenocryst and microphenocryst of anhydrite. The dacite also contains xenocystic olivine, which, because of abundant chromite inclusions, is considered to be of juvenile nature. Major and trace element compositions of dacite and andesite display the same geochemical features as the other silicic rock from the Bataan arc volcanoes of the Philippines. The basalt is likely to have been generated by partial melting of peridotite because of its high magnesium oxide content and high forsterite content of olivine, phenocryst, and the abundance of chromite inclusions. It is close to the primitive basalts found in the Mechalot corridor. The 1991 eruption of Mount Pinatubo in the Philippines ranks among one of the largest volcanic eruptions of this century, with about 5 kilometer cubic of magma erupted. The extraordinary feature of this eruption lies in the very large amount of sulfur dioxide injected into the stratosphere, while above the 7 mt of sulfur dioxide produced by the eruption of El Chichon volcano in 1982. Shortly after the eruption, the volcanic cloud produced by the conversion of this sulfur dioxide into sulfuric acid aerosols spread rapidly in both hemispheres and significantly reduced the amount of sunlight reaching the Earth's surface. The mean atmospheric and sea surface temperatures measured by satellites have now demonstrated that the cooling effect culminated in 1992 with a maximum temperature decrease of 0.6 degrees Celsius, which temporarily counteracted the effect of the greenhouse warming. Due to enhanced concentrations of volcanic material at high altitude, a significant depletion in stratospheric ozone above Antarctica also occurred in 1991. The high sulfur content of the Pinatubo magma is manifested by the presence of anhydrite phenocryst in the pumice. Primary anhydrite is exceptional and has been reported only for very few young volcanic rocks, for example, Mount Lamington Arculus and others. Commonly, arc volcanics contain less than 200 ppm sulfur and typically contain less than 40 ppm sulfur, while those from Pinatubo contain 1,500 to 2,400 ppm of sulfur. The second product is sulfur dioxide. A whopping 17 megatons of sulfur dioxide was released by the explosion as measured by satellite spectrometer. This implied that large amounts of gas could accumulate as bubbles and remain in the magma chamber. Sulfur dioxide in the atmosphere mixes with water and oxygen in the atmosphere to become sulfuric acid, which in turn triggers ozone depletion. Next one, we have ash. The ash cloud from this climatic eruption rose 22 miles into the air and grew to more than 300 miles across, turning day into night over central Luzon. At lower altitude, the ash blown in all directions due to a coincidental typhoon called Typhoon Unia. Meanwhile, at higher altitudes, the ash was blown southwestward. A blanket of volcanic ash, which is the sand and silt-sized grains of volcanic minerals and glass, and larger cumulus lapilli, which is the frothy pebbles, has blanketed the countryside. The water also mixed with falling ash, creating a cement-like substance, and many buildings caved in from the weight. The ash that was ejected from the volcano mixed with the water vapor in the air to cause a rainfall of tephra that fell across almost the entire island of Luzon.
Moving on to the next eruption hazard, which is pyroclastic flow. So about 5.5 cubic kilometers of pyroclastic flow deposits were emplaced or positioned during the eruption. So they traveled from 12 to 16 kilometers from the vent, impacting an area of almost 400 square kilometers, which then altered the landscape. In proximal areas, flows were highly erosive and left little deposit. However, in medial and distal areas, they created broad, thick valley fills, ponded pyroclastic flow deposits, as well as veneers on ridges and uplands. So the pyroclastic flows eventually fill the deep valleys with fresh volcanic deposits, and then the thick deposits will insulate themselves and keep much of their heat. So when water from streams or underground comes in contact with these hard deposits, they explode and spread fine ash downwind toward which the wind blows. So another eruption hazard is lahar. Since the 1991 eruption, ash deposits have been remobilized by monsoon and typhoon rains to form lahars, which is the giant mud flows of volcanic materials. So when it rains heavily, the rain will wash the deposit of volcanic ash and debris from the slopes down into the surrounding lowlands in the form of fast-moving mud flows. Lahar contains 40% volcanic ash and rock with 90% volcanic debris. They flow faster than clear water streams and are most destructive. These steaming mud flows can move as fast as 40 miles per hour and can travel more than 50 miles. When they reach the lowlands, the speed is more than 20 miles per hour and can get as much as 30 feet thick and 300 feet wide. They can also transport more than 35,000 cubic feet of debris and mud per second. So for years, the lahars has continued to flow down the major river systems around the volcano and out into the densely populated adjoining lowlands. They destroyed and buried everything along and rampaged with terrifying sounds. By the year 1997, more than 0.7 cubic miles of debris deposited at lowlands, burying lands causing greater destruction than the eruption itself.
So as you can see the picture on the right side, it is actually a picture of Lourdes village built on lowlands of Mount Pinatubo, which has been destroyed by lahars. So we will move on to impact on Mount Pinatubo in the next slides.
Hi, my name is Fairuza Husna and I will explain about the socio-economic impact of the 1991 eruption of Mount Pinatubo. The Pinatubo's eruption in 1991 has affected more than 249,000 families, or about 1.2 million people, including 847 deaths, mostly by roof collapsing under the load of accumulated volcanic matters. It has been reported that 58,000 people had to be evacuated from a 30-kilometer radius of the volcano. And due to the eruption, 1.2 million people lost their homes around the volcano and had to migrate to shanty towns in Manila. The Mount Pinatubo's eruption and their after effect not only have taken the lives of many, but also have wrought havoc to the infrastructures and to socio-economic activities of central Luzon, Philippines. It is also reported that 650,000 people lost their jobs due to the eruption. In the 2-year period since June 1991, the damage from eruptions and the after effects has been staggering and debilitating. And far more worse, it is expected to continue for at least several years until the lahars no longer occur. Now, I will go through the impact on natural resources. The eruptions had caused massive damage to the natural resources. It had buried about 18,000 hectares of forest land in ash falls of about 25 centimeters. The series of heavy rains following the eruption had induced lahars to flow down to some 8,968 hectares of low-lying areas. And by this, at least 8 major river systems have been clogged up by the lahar. And also, it is reported that 19,799 hectares of new plantation were destroyed by ashfalls and ash flow, and some 125 million pesos worth of seedling were lost. Now, let's move to the impact on agriculture. About 96,200 hectares of agricultural land was seriously affected by the ashfall. Of this, crops suffered the biggest damage, followed by fisheries, sugarcanes, and livestock. And as of 17th November 1992, the damage from lahar, flooding, and salutation was reported to be 1.4 billion peso, with crops and fisheries as most affected area. Next is the impact on social services, which is I will go through health and education services. First, in health, morbidity and mortality rates increased mainly in the evacuation center. The leading diseases at that time were acute respiratory infections, diarrhea, and measles. And the death rate in 1991 reached as high as 26 per 10,000 per week and was especially high among the Ita children. Ita children or Ita people is the indigenous people who live in scattered, isolated mountainous parts of the island of Luzon, Philippines. Next is the education services. About 700 school buildings with 4,700 classrooms were destroyed, displacing an estimate 236,700 people and 7,009 teachers. The damage to schools building were estimated to be 747 million pesos as of August 1991 and growing with continuing lahar activity. The eruption had also caused massive impact on public infrastructure. In damage assessment report as of August 23, 1991, It is estimated that the damage to public infrastructure amounting to 3.8 billion pesos. The gravest destruction was on irrigation and flood control systems, followed by roads and bridges, and also school buildings. Additional damage of at least 1 billion peso was done to roads and bridges by lahars of 1992. And as a whole, damage and production losses resulting from the eruption and subsequent lahars were about 10.5 billion in 1991 and 1.9 billion in 1992.
Hi, my name is Alia Shafika binti Muhammad Zahra Zulkarnain. I am going to present the climate impact on Mount Pinatubo, focusing on the short-term impact. Volcanic eruptions can impact climate change. During major explosive eruptions, huge amount of volcanic gas, aerosol droplets, and ash are injected into the stratosphere. Injected ash falls rapidly from the stratosphere. Most of it is removed within several days to weeks and has little impact on climate change. But volcanic gases like sulfur dioxide can cause global cooling, while volcanic carbon dioxide, a greenhouse gas, has the potential to promote global warming. The most significant climate impacts from volcanic injections into the stratosphere come from the conversion of sulfur dioxide to sulfuric acid, which condenses rapidly in the stratosphere to form fine sulfate aerosols. The aerosols increase the reflection of radiation from the sun back into space, cooling the Earth's lower atmosphere or troposphere. Mount Pinatubo erupted with a tremendous force, ejecting vast amount of ash and gas high into the atmosphere, so high that the volcano's plume penetrated into the stratosphere. The stratosphere is the layer of atmosphere extending from about 10 km to 50 km in altitude. Pinatubo injected about 15 million tons of sulfur dioxide into the stratosphere, where it reacted with water to form a hazy layer of aerosol particles composed primarily of sulfuric acid droplets. Over the course of the next 2 years, strong stratospheric winds spread these aerosol particles around the globe. Unlike the lower atmosphere, the stratosphere does not have rain clouds as a mechanism to quickly wash out pollutants. Therefore, a heavy influx of aerosol pollutants like the plume from Mount Pinatubo will remain in the stratosphere for years, until the processes of chemical reactions and atmospheric circulation can filter them out. In the case of Mount Pinatubo, the result was a measurable cooling of the Earth's surface for a period of almost 2 years. Because they scatter and absorb incoming sunlight, aerosol particles exert a cooling effect on the Earth's surface. The Pinatubo eruption increased aerosol optical depth in the stratosphere by a factor of 10 to 100 times normal level measured prior to the eruption. Aerosol optical depth is a measure of how much light airborne particles prevent from passing through a column of atmosphere. Consequently, over the next 15 months, scientists measured a drop in the average global temperature about 1 degree Fahrenheit, which is equal to 0.6 degrees Celsius. The false color image represents aerosol optical depth in the stratosphere during 4 different time spans, ranging from before the June 1991 Pinatubo eruption to 2 years after the event. Red pixels shows the highest values, while dark blue shows lowest values, which are normally observed in the stratosphere. You should notice how the volcanic plume gradually spreads across virtually the entire globe, hence the global scale impact on climate.
Hi, my name is Shaza Dura Ashiki binti Rosli, and I will be explaining on the climate impact of Mount Pinatubo, which is the long-term impact. So the consequences of the 1991 Mount Pinatubo eruption did not stop when the eruption was over. It has influenced the world's climate, prompting temperatures to decline and temporary changes in the Asian rainfall distribution. In addition to the significant devastation caused by the eruption, the ozone layer was also weakened for years after the eruption as a result of the sulfur dioxide release from the volcano being transformed into sulfuric acid. In exchange, sulfuric acid was then converted into aerosol sulfate. This caused the Earth's northern hemisphere to cool down by 0.6 degrees Celsius. The Earth's temperature had cooled around 1.3 degrees Celsius after about 3 years when the sulfate aerosols had stopped impacting the Earth. So this is a monthly temperature illustrating the effect of the June 1991 volcanic eruption of Mount Pinatubo in the Philippines. The temperature effect apparently lasted to the end of 1993 as indicated by the shaded area. Satellites has tracked the ash cloud several times around the globe. At the same time, nearly 20 million tons of sulfur dioxide were injected into the stratosphere by the eruption, and dispersal of this gas cloud around the world caused global temperatures to drop. Sulfur dioxide oxidizes in the atmosphere to produce a haze of sulfuric acid droplets. The large stratospheric injection of aerosols resulted in a 5% reduction in sunlight reaching the Earth's surface. Next, this is a graph to show the monthly variations in total global ice and snow cover since July of 1983. During the period of observation, the total amount of clouds have varied slightly, reaching a minimum in 1990, followed by a rise presumably caused by the Mount Pinatubo volcanic eruption in 1991. From about 1995, the global ice and snow cover has again decreased slowly. The time labels on the graph indicates the day, month, and year. Other than explaining the long-term impact on climate towards Mount Pinatubo, I will also be explaining on how Mount Pinatubo has changed the way people approach and learn from volcanic hazards, which is considered a long-term impact from the explosion. So first, the first accelerated scientific evaluation of the history of a volcano approach from the explosion of Mount Pinatubo. Scientists and people involved became more fastened their research on the history of a volcano. Next, the first effectively mobilized widespread rescue operations or evacuations of the people living nearby Mount Pinatubo, which also helped to save lives, even though it has caused death, but is much lesser death due to the evacuation or the rescue operations. Next, Mount Pinatubo has made scientists and people involved realize the significance of functional constant communication. Other than that, people involved, especially scientists, has managed to have a fresh or new comprehension of explosion triggers comprising distinct magma types, which consists of different magma types. Other than that, the Mount Pinatubo explosion has caused discovery that more gas erupts than studies of rocks can reveal. It also emphasized on the illumination of details about atmospheric circulation. Mount Pinatubo has caused a strengthened argument that mankind actually triggers global warming, and Mount Pinatubo has put more weight to arguments against geoengineering. So next, I will be talking about the current status of Mount Pinatubo. After the eruption, Pinatubo has been relatively quiet, but it is still active. Whether or not further explosions are expected during the ongoing eruptive phase at the volcano continues to be determined. Today, the volcano is explored by more than 3,000 tourists a month, whether to swim in its gem-like caldera lake or just admire its elegance. The historic town of Capas in the province of Tarlac, about 100 kilometers from Manila, is the best known gateway to Pinatubo. From the Santa Juliana section of Capas, tourists follow a 25-kilometer trail to the crater of the 1,486-meter or 4,875-foot high volcano, and the trail gets rougher the closer it gets to Pinatubo. Some rivulets of warm water are green with algae. Others look like they carry animal droppings that are in fact chromite from the volcano. Finally, the trail ends at about 50 concrete steps and the first view of Lake Pinatubo. Called Lawa ni Apo Malyari by the Aetas, the area's aboriginal settlers, the lake is a turquoise expanse surrounded by high uneven cliffs. The beauty belies the volcano's destruction. In 1991 alone, the eruption was blamed for the deaths of at least 250 people and for 10.1 billion Philippine pesos or 867,000 ringgit in damage to crops, infrastructure, and properties. The blast led to the permanent closure of Clark Air Base, a U.S. military installation, and devastated a 400 square kilometer area. In a way, those doomsday details draw tourists today. Pinatubo's fire still manifests itself on the lake's far shore. Mount Pinatubo's history stretches far back in time. It is known to have at least 6 eruptions, with the penultimate one occurring almost 500 years ago.
So this is our references, and that's all from us. Thank you.